Hello students, I am Surendra Jain, Master Teacher in Vedantu. I have brought a series for KVPY SA stream preparation in mathematics. Last time we talked about geometry in triangles and today I will be talking about geometry in circles. So first I will be taking up few important concepts, theorems, and then we will be applying them in some good questions. Okay, so let us start with this theorem. This theorem, Ptolemy theorem, one very important thing in a cyclic quadrilateral, it says that in cyclic quadrilateral the product of diagonals. So if we go with this diagram where ABCD is cyclic, so the diagonals are AC and BD, so their product is equal to sum of product of opposite sides. So you can see AB and CD are opposite and AD and BC are opposite. So here AC into BD is equal to AB into CD plus AD into BC. So that is what Ptolemy theorem says. Now one more important thing here, that for any convex quadrilateral if we take, maybe they are cyclic or they are not cyclic, this AC into BD will always be less than or equal to AD into BC plus AB into CD. But this equality will hold only for cyclic quadrilateral. So for any other quadrilateral other than cyclic, there will be strict inequation. Okay, so let us see how we can apply this Ptolemy theorem in the questions. So I have taken one question based on equilateral triangle. It says a line is drawn from the vertex A of an equilateral triangle ABC which meets BC at D and circumcircle at P. So we have to prove one, that AP is equal to BP plus PC. Okay, so if we make diagram like this, then you can see that A, B, PC is cyclic. And if it is cyclic, then the diagonals are AP and BC. So their product as per Ptolemy theorem should be equal to the sum of product of opposite sides. So we will have AB into PC. AB and PC are opposite sides, and other two opposite sides are AC multiplication with PB. Okay, now because this is equilateral triangle, hence this BC, this AB and this AC, they all will become equal, so we can cancel them, and this gives us the required result that AP length will be equal to PC plus PB, and that's it. Okay, now coming to the second part, which says 1 upon PD is equal to 1 upon PB plus 1 upon PC. Now to prove this, we will make use of this first part first, and then we will use some similarity of two triangles, then we can prove it easily. Please see, if I divide this first result by PB into PC. Okay, so my left hand side will become PA upon PB into PC, and right side will become 1 upon PC plus 1 upon PB. Let me call this as some equation number 1. Now I have to prove that this PA upon PB into PC will become equal to 1 upon PD. Okay, now to prove this, I will use similarity in two triangles. And which two triangles? Please see. In such diagram, you can see there are many angles which are equal. For example, this PB or BP will subtend same angle, let us say alpha, at A and at C here. Okay, now this AC is subtending 60 degree at B, and hence it is subtending same angle 60 at B also, at P also. Similarly, this AB is subtending 60 degree at C, so it is subtending 60 degree at P also. So I think it can be seen that triangle APB is similar to triangle CPD. It can be checked. At A, the angles are same alpha alpha. At P, angles are 60, and angle at P here, they both are 60, and then remaining angle will have to be same only, because from that angle sum property. So these two triangles are Similar, I can say from criteria AAA, because all three angles are equal. Now, if I compare the corresponding sides, so in this triangle APB, I am taking, I have to prove PA, so I will take this as one angle, okay, and corresponding to this angle in the triangle CPD, we will have same angle at D. So let me take side opposite to this angle in this triangle APB, it will be AP here, okay, and side opposite to alpha will be BP here. Whereas in this triangle, if we take the corresponding sides, it will be side opposite to this angle D will be PC upon side opposite to alpha will be PD. Okay, so I think we are done. We have got that AP or PA, it's the same thing. AP upon PB into PC will be equal to 1 upon PD. Okay, so this is equation number 2, and let me write this equation 1 now, and we can write this as 1 upon PB plus 1 upon PC is equal to 1 upon PD. That's it. This completes my solution for the second part. Okay, now coming to next question. This question says point M is the midpoint of arc of a circle. So one very important thing before we proceed, if for this arc AC M is the midpoint, then this AM has to be equal to CM, isn't it? Because if it's a midpoint, so this arc length AM will be equal to arc length CM, and hence this direct length AM will also be equal to CM. Then we are given point B on the minor arc AM, and F is a point on CB such that MF is perpendicular to BC. So this angle is 90 here. And so we have to prove that this FC is equal to BF plus AB. Okay, now to prove this, I will do some construction, but let us understand what are the things that we are already aware or we already know. So we know that AAM length is equal to CM length. Okay, and this angle here, let us call this as alpha. So this angle will also be alpha because this angle is subtended by the arc BM on A and on C in the same circle. So these two angles are equal. Now, if I take a point on this FC called as D, okay, so that this AB is equal to DC. AB is equal to DC. Then you can see, and let me mark this as this. So you can see this AB equal to DC and this MA is equal to MC, and angle included between them are also equal. Hence these two triangles, I join B with M and I join M with D. I think it can be said directly that triangle AMB will be congruent to triangle, I think here in place of A it will be C, in place of M it will be M once again, CM, and in place of B it will be D here. And from which criteria I am talking about? I think side, angle, side. You can see once again AB and AM are two sides in this triangle, whereas DC and CM are the two sides in the other triangle, and angle included between them is same alpha. So from this we can say this BM will become equal to MD. BM will become equal to MD, and hence we can say this triangle BMF will become congruent to triangle DMF. Why I am saying so? Because in these two triangles you can see this MF are the common sides, so they are equal, and BM is equal to MD are equal, we have proved it, and angle F is equal to angle F is equal to 90. So from that RHS criteria, right hypotenuse side criteria, these two triangles become congruent, and hence their other corresponding sides should also be equal. So I can say that this BF will be equal to FD. And now I think we are done. what we were supposed to prove? We were supposed to prove that FC equal to BF plus AB. So here FC can be easily written as FD plus DC. We have proved this FD to be equal to BF, and we took D point such that DC is equal to AB. So we will write DC as AB, and that is what we are supposed to prove, and hence it is done. So very easy question based on some properties of cyclic, or you can say angle in the same segment, and then properties based on congruency. It is done. Okay. Now coming to next question. But before that, let me introduce few more concepts on the circle. The tangent at any point of a circle is always perpendicular to the radius through that point of contact. That is one very important thing. I think it's very much known to students also. Now this is one very important thing. Please see, if you have a tangent AP, okay, and if you join A with some other points B and C, then there are few things that we need to take care of. Suppose triangle ABC is inscribed in a circle whose center is O, and P is a point in a plane, then these three things are equivalent. What are these three things? That if PA is tangent to circumcircle of triangle ABC, then if you join O with A, this OA will be perpendicular to AP. So that is, I think, something we have already talked about in our last slide. Then third thing is this angle PAB, okay, this angle here will be angle ACB. This is also known as alternate segment theorem. Alternate segment theorem. Why we are saying alternate segment theorem? You can see this tangent AP is making an angle with AB. For this AB, if you take angle on that other side of this AP, okay, so this angle will be always same as this angle. If we would have made tangent this side, okay, and then if I take this angle, okay, in that case this angle will become equal to what AC is subtending at B. So this angle will become equal to this. So here any one of these three things will imply the other two. Okay, so even if we are given this third point, then we can conclude this P point will be a tangent, and hence OA will be perpendicular to AP. So these three things are equivalent to each other, and we will be making use of this thing in many questions. One more thing, that from external point P, if we draw two tangents to the circle like this, PA and PB, then the length of PA, PB, they are equal, and center lies on the angle bisector of these APB. So these two angles will be same. Okay, and tangents AP and PB, they subtend same angle at O. I think this is one very obvious thing which one can prove easily. In fact, it is done in 9th class or 10th class maybe. And one more thing I will add here, that is that quadrilateral APBO is cyclic. Why I am saying so? Because you can see angle at A is 90 because OA is radius and PA is tangent, and similarly here also it is 90. So sum of these two angles is 90 plus 90, 180. So this quadrilateral becomes cyclic. Okay, and I think PO will be the diameter of this circle, which will be passing through all four vertices. So that is also one important thing we should remember. Then coming to secant theorem, or we call this as power of a point with respect to circle. So please see what it is, that through any point P, if we draw two chords AB and CD which are meeting at P, then product of two segments of these two chords, so PA multiplication with PB, will be equal to PC multiplied with PD. This is also called power of point, power of P with respect to circle. Okay, we will talk about this, or you will study this in detail in your 11th class circles chapter. Okay, in fact this P point may be lying outside also. So if from P you draw AB and DC, do two chords, then also this PA into PB will be equal to PD into PC. In fact, there is one more thing to look at the same property, that if P point is lying outside and we draw a tangent PT and a chord AB, then this PT square will be equal to PA into PB. Okay, in fact from P you may draw many such chords. Let us call this as C here and D here. Then we can write this as PT square is equal to PA into PB is equal to PC into PD, and so on. Okay, so that is one more important thing. Now coming to this one very important question, or one very good question based on what we have done just now. This question says in the diagram below, ABCD is cyclic quadrilateral with AB is equal to AC, and FG is a tangent at C point and is parallel to BD also. And we are also given that AB is 6 and BC is 4. And we have to find the value of 3 times AE. Now to do this question, let us do some angle chasing. Let me call this angle as alpha. So because this GC is a tangent at C, so from alternate segment theorem, this CD will subtend same angle at A. Okay, and there will be the same angle at B also. Now because BD is parallel to FG, so this angle will also be alpha. And once again from the alternate segment theorem, I think this BC will be subtending same angle alpha here as well. Okay, also because BD is parallel to FG, so this angle at D will also be same as alpha from that alternate angles, because two parallel lines, one transversal is cutting them, so these two angles will be equal. Now I think we have proved that CD will be equal to BC and this will be equal to 4. Okay, apart from this, please see, if I compare this angle at E, it should be actually equal to, and let me call this as beta. This has to be sum of these two angles. Actually this angle B is exterior angle of the triangle AEB. So this beta has to be, let me call this angle as gamma. So this beta has to be equal to alpha plus gamma. Okay, but we are having this as alpha and this also as alpha. So you can see in the triangle ABC, okay, we have proved that angle at E, angle BEC, let me call BEC, that angle at E is equal to angle at B. You can see, because angle at B will also be equal to gamma plus alpha, and this beta we have proved as gamma plus alpha. So angle at E and angle at B in these two different triangles are same. But because we were given that ABC was isosceles triangle and AB was equal to AC, so angle at C here will be same as equal to gamma plus alpha. So I hope it can be very clearly seen now that these two triangles has become similar. Why I am saying so? Because you can see in this triangle ABC, let me write them separately. So angle ABC is equal to angle ACB, and they both are equal to alpha plus gamma. And in this triangle BEC also we have proved this angle BEC is equal to angle BCE, and they are also equal to alpha plus gamma. So these two triangles are similar because remaining angle will also be same. In fact, it is written here itself, alpha alpha. So these two triangles have become similar. So if they are similar, let me write it separately. So triangle ABC is similar to triangle BEC. And let us see what is their ratio of similarity. If I check their corresponding sides, so I think the corresponding sides can be AB in one triangle and BC in the other triangle, isn't it? AB in one triangle and BC in the other triangle. So you can see their ratio of similarity is 6/4, that is 1.5. Okay, now let me talk about one more ratio of their corresponding sides. It should be equal to BC upon EC, isn't it? BC in that bigger triangle ABC, and corresponding to that in that smaller triangle EC is the side. So BC upon EC should also be 1.5, but we are already aware about BC. So if this is 1.5, so we will get EC directly from here. EC will be equal to BC, that is 4 upon 1.5. So it will be equal to 6 upon, it will be equal to 8/3 actually, 8/3. So from this we will be able to conclude the length of AE, because the complete AC is 6, because AC AB are equal. So AC minus EC is equal to 6 minus 8/3. So this becomes 10/3. So if AE is 10/3, 3 times AE will be equal to 10. So answer for this should be equal to A. Now coming to this question, which says in a triangle ABC, AB is 36, BC is 40 and CA is 44. The bisector of angle A meet BC at D and circumcircle at E different from A. So we have to find square of this length DE. Now first of all, because this AD is angle bisector and we know that this CD upon DB ratio has to be equal to this 44/36, which is 11/9. That's a very important theorem with the name angle bisector theorem. So this ratio will be 11/9, and because complete BC is 40, okay, so it can be easily proved that CD will be equal to 22 and this BD or DB will be equal to 18. You can see the sum is 40, ratio is 11/9. Now to find this length DE, I have two methods. One method is using some power of point and cosine rule. Let me see how. Let me show you the path how it can be done. We have already found that this is 22 and this is 18. So if I take the power with respect to D, we will get DC into DB is equal to DA into DE. Okay, so here DC and DB we already know. So DE can be calculated as DC is 22, DB is 18 upon DA. Now to find DA, I have two methods. What are these two methods? Please see. One method is that there is a standard formula for length of angle bisector with 2BC upon B plus C into cos A/2. Okay, in this triangle ABC we have all the sides. So using cosine rule we can find cos A and then cos A/2 also. So that can be one method. That can be another method also, that if we apply cosine rule in these two triangles ADC and ADB, you can see this angle is theta, then this angle is pi minus theta. Okay, so taking cos of these two angles, so cos theta will be equal to how much? 22 square plus AD square minus 44 square divided by 2 into 22 into AD, that is cos theta. And similarly cos pi minus theta can be written as 18 square plus AD square minus 36 square and whole divided by 2 into 18 into AD. And as we know, cos pi minus theta is minus of cos theta. So equating these two relations with minus sign, of course, we will be able to get AD. And once we know AD, I think DE can be calculated from this result. So that is one way I have told you. Now coming to one more method, because this will require a lot of calculation, but we can do this without much calculation with the help of geometry. Let us see how. So in our previous slide, we wrote that AC is 44, AB is 36, we found CD to be 22 and this to be 18. Okay, and once again, because it's there is a cyclic quadrilateral, so many angles will be equal. Like this angle is a by 2 here, this angle is also a by 2 here, so this angle will be a by 2. BE subtending same angle at A and same angle at C. Okay, and also this AB, also this CE subtending A by 2 here, so CE subtending A by 2 here. Okay, now you can see that triangle AD, just 1 minute, this angle is equal to this angle, vertically opposite angle. Okay, and this angle is, I think, same as this angle B. Yeah. Okay, yeah, done. So I think we have a triangle CDE to be similar to triangle CDE. I can write ADB. I hope that is clear. CDE is similar to ADB from angle criteria. You can very easily see. Now what we can see from here now is if we compare the corresponding sides. So I'll take the ratio of CE with DE, CE with DE. It will be equal to, you can check, CE is opposite to this angle, and corresponding to this angle in that other triangle we have length 36, whereas DE was opposite to A by 2, here opposite to A by 2 we have 18, so we get this to be 2. So if I call DX to be DE to be X, so if we call this DE to be X, our CE will become 2X. So CE will become 2X. Now I think this question will become easy. How? Because we know this is 2X, and same this BE will also be 2X only. Now if I drop a perpendicular from E on this side BC, okay, and let us call this point as M. So this M has to be midpoint of this BC. The entire length is 40, so CM length will be 20, so this small MD will be 2. M is the foot of perpendicular from E and also the midpoint of BC, so this MD will become equal to 2. Okay, so we can apply Pythagoras theorem here. Please see how we can find ME square. We can find ME square to be equal to x square minus 2 square. I hope that is clear. ME square is equal to this ED is the hypotenuse of this triangle. I am talking about triangle EMD. Okay, so ME square will be equal to x square minus 2 square. Now use Pythagoras theorem in the triangle EMC also. So what we will get? We will get, I think, 2x whole square will be equal to CM square plus ME square. So 4x square is equal to CM is 20 square because M is the midpoint, so 20 square, and ME square we have found x square minus 2 square, or let us call this as minus 4 here. So bringing this x square this side, we get 3x square, and that will be 400 minus 4, and this will be equal to how much? 396. So x square will come out to be 132. So this is how this can be calculated with much more ease than what I was talking about in our previous methods. So this length DE square of this length DE is 132. Okay. This question, I have one more method. Please see how this can be done with another method. If I take this AD as Y, okay, then using the properties of power and Ptolemy theorem also it can be done. Please see how. Using power of point, I think we will be able to get this x into y will be equal to 22 into 18. Okay, and using Ptolemy theorem, we can write that 2x into 36 plus 2x into 44. Sum of product of opposite sides will be equal to 40 into x plus y. Okay, and if I simplify it, taking 2x common, it will become 2x into 80. On the right hand side, we are getting 40 into x plus y. So this 40x will cancel this 180x. So, or in fact 40, let me cancel this 80 two times. So we will get 3x is equal to y. Okay, so 3x is equal to y. Putting this y as 3x here. Okay, let me use this space here. So it will become 3x square is equal to 22 into 18. So 3 cancel this 6 times. So we get x square is equal to 132. So this is one additional method. So I hope you have understood all the 3-4 methods. I think this one is best method. I can say this Ptolemy theorem and power of point using this, I think it is the best. Otherwise you can do by geometry also. Now coming to next question. This question is triangle ABC has sides of length AB is equal to root 41 and AC is 5, BC is 8, O is the center of the circumcircle of triangle ABC and A dash is the point diametrically opposite to A with respect to O. Then we have to find the area of triangle A dash BC. Okay, so I have one method by which it can be done very easily, but if you know results of orthocenter and their property, then also we have additional method that I'll talk about later. But let me first do this question by geometry only. If I drop a perpendicular from A and extend to, let us say, point, let me call this point as D and this point as, let us say, D dash. So this is going to be 90 degree because A dash is diameter. So at D it will be 90 degree. In fact, DD dash will be the height of this triangle A dash BC. Okay, so if we can find DD dash, then I think we are done. Okay, and how we can find DD dash, please understand. We can find the angle C using cosine rule because we know BC is also 8. So please see, once we know the cosine of this C as it will be how much? 5 square, so 25 plus BC square, that is 64, minus AB square, that is 41, and upon 2 times 5 into 8. So if we simplify it, it becomes 89 minus 41, so 48 it will be, upon this will be 80. So by 16 if we divide, it becomes 3 upon 5. So if we know this angle C and this is 90 degree and this is 5, we can find the length AD. Okay, what will be AD? I think AD should be equal to 5 times sine C. Cos C is 3 by 5, so this will give 5 into 4 upon 5, so this will be 4. Similarly, we can find CD also. CD will be 5 cos C. 5 cos C, so this will be 5 into 3 by 5, so this is 3, and this DB length will be equal to 8 minus 3, so it is 5. So I think you must have guessed it right that at D point, if I use power of this point D, so we will get DC into DB is equal to DA into DD dash. And this DC we have calculated is 3, DB we have calculated as 5, DA we have calculated as 4, and DD dash we can find it now from this. So DD dash will become equal to 15 upon 4. Okay, I think finding area of this triangle is now just a trivial thing, but let me tell you, if you are not aware about cosine rule, then also this can be done. What you could have done here, you can take DC to be x, then DB will become, I am taking DC to be x, then DB will become equal to 8 minus x. Then using Pythagoras theorem, okay, writing AD square into different manners, and which is 5 square minus x square is equal to this 41 minus 8 minus x whole square. So solving that also, it will give you x to be equal to 3. And once we know x to be 3, then everything is known. Then using the same method of power, we will be able to get dd dash. So you could have avoided cosine rule if you do not want to use it or you are not aware about it. Then you can do it directly by Pythagoras theorem also. In fact, cosine rule is nothing but Pythagoras theorem only. If you go into the proof of cosine rule, you will find it is always proved using the Pythagoras theorem. Now we know dd dash, which is the height of this triangle a dash b. So what will be the area of triangle a dash bc will be equal to 1 upon 2 into bc into this dd dash. So this is 1 upon 2. BC length was 8 into 15 by 4. So answer for this will become equal to 15. So answer is 15. Okay. Yeah, I was talking about one more property or one more thing about this question. Please see. If you are aware, this d dash is the image of orthocenter of this triangle in the side BC. Okay, so this dd dash, will be equal to HD also. And dear all, this HD is standard result. This is equal to 2r cos B cos C, where r is the radius of circumcircle. Because we are aware about all the three sides of this ABC, so we can find r using formulas of solution of triangle. Cos B cos C can also be calculated as I have done for cos C. So using that HD can be found, and it will be same as 15 by 4 only. It can be checked, and then you can find the area of this triangle A dash CB. In fact, area of this A dash BC will be same as area of HCB also. Okay, in fact, let me tell you, this is actually a parallelogram. You can prove it yourself that HCA dash B is a parallelogram, where CB is a diagonal. So area of triangle above it or below it will be same. So even if you find the area of triangle HCB, that will also be same as 15. Now coming to this question, ABCD is a quadrilateral inscribed in a circle and diagonal BD bisects AC. So let me call this as A, and this will also be A. AB is 10, AD is 12, DC is 11. We have to find BC. Now please see, here we can see this angle will be equal to this angle. So you can see if this point is O, so triangle OAB becomes similar to triangle ODC, OAB, ODC. Yeah. Now you can see this ratio of similarity is 10 upon 11. You can just compare the sides opposite to these two same angles, 10 upon 11, and this will be equal to A upon, here it is OD. So from this we get OD to be equal to 11A by 10. Now using power property of this point O, you can see OB into OD will be equal to A into A. So this gives us OB to be equal to 10A upon 11. So this was 11A upon 10. This will be 10A upon 11. Now there are two more triangles which are similar, and they are, please see, because this BA will subtend, let us say, angle beta here, and this will subtend same angle beta at here also. So which two triangles will be similar? I think OBC will be similar to OAD. Yeah. So here if we take the ratio of corresponding sides, so we will get here 10A upon 11 divided by A will become equal to x in this triangle upon 12 in that other triangle. So from this we get x to be equal to 12 into 10 upon 11. So we get this answer to be 120 upon 11. So the length BC will be this thing. I think very easy question based on just use of some similar triangle. Now coming to this question which says let ABC is acute triangle and BECF be the altitudes of triangle ABC. So this angle is 90 here and this angle is also 90 here. And denote by M the midpoint of BC. Prove that ME and MF and the line A through A parallel to BC are all tangents to circumcircle of triangle AEF. So let us do this question one by one. First of all, because these two angles are 90-90 each, and let us call this point as H. So I think it is very easy to say that AFHE is cyclic, because sum of opposite angles is 90 plus 90, that is 180. So this circle passing through AFE has to pass through H. In fact, if I join this A to H, this AH has to be diameter of this circle. So its center will be lying somewhere here. In fact, because CF and BE are the altitudes, so their point of intersection has to be orthocenter of this triangle. And if I join AH, it should be another altitude of the same triangle. So let me call this as AHD. Okay, so I think one part is very direct here. Please see how. Because this, let me call this as XY. So this XAY is parallel to BC. And this AD is perpendicular to BC. So this angle will also be 90 only. And because AH is the diameter, so this AH is perpendicular to AX or AY. So hence this XAY is a tangent at A point. I think this way we can directly say, at least for this thing. Okay, so one part is done, I think. So let me write this once again. AH is diameter and perpendicular to BC and XAY. So this XAY is tangent at A. That is one part. Now coming to another part. Please listen carefully. This triangle BEC is a right triangle at E. Okay, and M is the midpoint of BC, and BC has to be hypotenuse. So this midpoint M has to be at same distance from E, C and B. So this length will also be same as CM and BM. So I can conclude this angle will be same as this angle, that is C. Now from this we can say this angle HEM will become equal to 90 minus C. As this complete angle is 90, so angle HEM will be 90 minus C. And also this angle HAE, because this here it is 90, this is C, will also be 90 minus C. So you can easily see that the angle which ME is making with HE here is same as this angle. So from that alternate segment theorem which we discussed just now, just some time back here in this session itself, I think this ME has to be is tangent to the circle. If you remember, let me just remind you, we did this theorem here. Any three of them imply other two. So if this angle PAB is equal to ACB, then PA will be tangent to the circumcircle of triangle ABC. So this is exactly what I've used here. Okay, same way we can prove this MF will also be the tangent of the same circle. Now I'll be talking about teaser question of this session, but before that let me tell you KVPY sessions are held every Sunday for physics, chemistry, maths and bio for SA and SX stream at these timings. So please follow these sessions. If you are JAIN advanced aspirant, then you must know about Vedantu Eklavya. If you are not aware, please Google it, you will come to know. It will help you in a big way for your JAIN advanced preparation. This is a link of notice board and this is the QR code for the same, where we are putting all sort of information regarding new batches or anything new things coming up in these batches. So please follow this notice board. This is the link and QR code for students who are going to write JEE Advanced this year. You will be taken to Telegram channel where we are putting all informations about Eklavya batches and how you can join them. Similarly, for 2023 students and 2024 students, you can join these Telegram channels. All these links are shared in the description box also. Dear all, we have created one YouTube channel with the name VImpact, where you will find solutions of KVPY and JEE. These solutions are question wise. As of now, these many years are there, and we are increasing the number of years in this channel very soon. Okay. Now let me come to the teaser question. This question is that perpendiculars BD and CE are drawn from vertices B and C of triangle ABC to the interior bisectors of angle C and B, meeting them at D and E respectively. We have to prove that DE intersects AB and AC at their respective point of tangency, F and G, with the circle that is inscribed in the triangle ABC. Please make a fair diagram. You will understand what exactly is given and what exactly is asked. If you have solved this question, you just send your solution to this email ID eklavyasupport@vedantu.com with the subject line teaser solution maths. We will check your solution. We will revert you on the same email ID from where you are sending. So if you are sending multiple solutions, let us say for maths, physics and chemistry, then use the same email ID so that we can track where from we are getting these solutions. If we like your solutions, we will contact you to make part of our programs. Okay. So that is all for today. Thank you so much, everyone. Bye.